Hi everyone, today we're discussing the risks and uses of radiation. Now, you'll know that alpha, beta and gamma radiation, they can be quite dangerous, alpha being the most ionising, gamma being the least. Today we're going to look at some of the risks of that and also some of the ways that we use radiation, because it is a very important thing that we can use radiation for our advantage as well. We're going to focus on the risks first, then we'll talk about the uses. So, the risks of radiation. If you have a low dose of radiation, it probably won't kill the cell that it's affecting. Okay, so we look at our bodies, we're made up of lots of different cells, you know that from biology. Today we're just going to focus on the cell and the nucleus. Okay, really, really simple. So we get a low level of radiation coming into the cell. Okay, we'll just do this symbol for radiation, make it nice and easy. So, radiation coming, it hits the cell. This can, very, very simply, cause the DNA to mess up a little bit. Okay, it becomes not what it was. It mutates. Okay, it's a good word for it. So let's say this cell is now mutated. It's now a dangerous cell. It's not working functionally. What can happen is it can start growing and dividing uncontrollably. When that happens and it starts to divide uncontrollably, that's when it's a problem. Okay, it's got no control on what it's doing. It's just dividing, and what that can happen is that can form a tumour. So with low levels of radiation, it can form a tumour. Now, high levels of radiation generally just kill cells. So if we get a high level of radiation hitting our cells, it will just kill it. Okay, and we're going to talk about why that might be important to know that later on. So low levels of radiation can cause uncontrolled cell division, which can cause a tumour, which is obviously cancer. Okay, and that's one of the main risks of radiation. Now, what actually happens to the cell depends on how much exposure it's had, so how much radiation has hit it, and also the ionising power of that radiation. Obviously, if alpha does this, it's very, very dangerous. It will just kill the cell probably. But if you've got gamma, it's a little bit different. Okay, so depends on how much exposure it's had and how ionising the type of radiation is, how powerful it is that's actually hit the cell. Now, although that sounds very, very dangerous, and it is, so we need to be careful in how we use radiation. We do use radiation in medicine, which might make no sense, but it does. So, for example, we use medical tracers. Okay. Now, all a medical tracer is, it's a radioactive isotope. Iodine is a good example of it. It's just an isotope of iodine that you inject into your body at a certain point, and doctors can trace, using special scans, where that radiation is going. Let's say you've got a blockage in part of your body somewhere. Let's say in the digestive system, maybe they can check that by saying, right, the radiation stopped there and it's not going through, so there must be a blockage there. So medical tracers are used for that. Now, a nice application question they can ask you in the exam is, what properties would you want from that medical tracer? What properties would you want from that medical tracer? And there's two main properties that you'd really want. One, a short half-life. A short half-life means that it's not around as much, there's not as much time to get exposed to that, there's less of a risk of developing cancer. So short half-life. Number two, you should probably want it to be gamma radiation, mainly because it's so penetrating, it's probably just going to leave the body and not affect anything. Again, lowering the risk of cancer. So that's medical tracers. Two key properties again, short half-life and probably gamma. We also use radiation in radiotherapy, so in the name. And what we do is we use it to target cells. We just learned that high doses of radiation just kill cells. So if you could kill these bad cells, this bad tumour, and target it with radiation, then you're going to kill the tumour and hopefully get rid of the cancer, or at least reduce it. The problem is that when you give someone high levels of radiation, high dose of radiation, it's going to kill more cells than just these ones, which is why you get a lot of illness, okay, and all the other symptoms that go along with having radiotherapy. But the idea is this: you get a high radiation dose, and it kills those really bad cells. Now, the kind of radiation you want to use for that is probably beta, because it's not like alpha. It's not really, really ionising. It's ionising enough to kill some of these, and it's not too penetrating. You just want it to stay inside the body because you want it to hit those cells, unlike in the medical tracer. So that's radiotherapy. Last thing we're going to talk about in this session is weighing up the risks. Now, scientists have to weigh up the risks and benefits of using radiation, because whenever you use radiation that's ionising, there's always going to be a risk of developing cancer, always. Might be really, really small, but there's always one there. But usually, when doctors use it, the benefits outweigh the risks. For example, if I have a really bad break in my arm, I'm going to want an X-ray. Yes, it's a little bit dangerous for me, but actually, it's really important to see what's going on, because I need to get that arm set in the correct way. And the doctors know what they're doing with that. If I have cancer, I'm going to want radiotherapy, because it is risky. There is risk attached to it, but I'm going to want it because I want a chance of killing that cancer off. So doctors and scientists always are weighing up risks all the time when they're using radiation in medical treatments. I hope that helps. So what we've done there is we've covered the risks of radiation and some of the uses of radiation and how we might use some of those in the exam as well, where they ask us some tricky questions. Thank you very much.